our previous video, we took a look at how parallel lines could divide up segments in a triangle proportionally. It turns out that angle bisectors, this piece right here that splits this angle in two, also divides triangles up proportionally. And as we talked about in our last video as well, there's many proportions that we can write to find the value of x. Now that doesn't mean every proportion works, we have to make sure we're consistent, but let me show you a few proportions that we could do to solve this. And I like to do this visually so I can see what parts are matching up. So one way to do this, one proportion I could write, is I could match up this piece and that side of the triangle over there. So 4 over 8 could be equal to, since I started that way, I'm going to start with 6 over x for the other proportion. So once I have it set up, it's simply a matter of cross-multiplying and dividing. That's one way to solve a proportion, to find the value of x. Well, I guess let's go ahead and get the answer right now. So I'd say 4x is equal to 48, and then dividing both sides by 4, I get an answer of 12, so x is 12. Now that's not hard to do. Let me just go ahead and show you, not to make this more complicated, but just show you some other proportions I could write as well, and watch how I can be consistent in how I set these up. So suppose instead I wanted to do 8 over x, I could start with those two sides matched up. As long as I did that, I just have to make sure, since I did 8 to x, I'm going to go 4 to 6 to match those up as well. I'm consistent in how I set this up. You can see that once you cross multiply and solve this, you'll get the same value. Something else, I mean, there's many more you can write. Let me write one down. You tell me whether you like the proportion or not. Suppose I did, let's say, 6 over 4. Let me say, start with that. So 6 over 4. Could I match that up to 8 over x? Would that give me the same answer? And if you're saying no, which hopefully you are, you're correct. The reason that this did not work is I was not consistent. 6 and 4 sort of went on the right side to the left side. 8 to x went in the other direction. So that proportion would not work. It's an example of not being consistent. Although that one would be just fine. Okay? And then one more example. Let's again try a few different proportions and see if we can get this set up consistently. So I have that bisector. I'm going to try to set this up as 7 over 13. I think I would start with that. So the 7 piece over 13 should be equal to this piece, which I don't know yet, over x, which is this piece right here. The number that I'm not going to be using is 15. I don't use that full side. That's not being consistent in how I set this up. Instead, though, I want to find out what that piece is right there. Here's where the 15 will be important. Since I know that entire side from Q to S is 15, I know that it's going to be 15, but then take away this part that I don't want to include, so I'm going to do 15 minus x to represent that piece up there. That's the only reason I have a 15 included in this problem. I'm not going to use that full side in my proportion. So once I have this set up, again, there's many other proportions we could write, but I'm going to choose to use this one. Let's go ahead and solve this by cross-multiplying. So I get 7x is equal to, and then when you cross-multiply this way, just be sure you distribute. 13 times 15 is 195, and then minus 13x. I'm going to add 13x to both sides to solve this, so 20x is equal to 195, and if I finish by dividing both sides by 20, I come with the value of 9.75.